I think it's obvious here that this is going to be a chain rule problem. I can see immediately that we have a mother function of the third power, right? So if we're going to use, do you guys want to use substitution or you just want to use chain rule? Substitution? Do you like substitution?
No, chain rule.
Let's
Vote.
all right. Let's just do the chain rule. I'll go back and do this with substitution after this, but let's try to do it with just substitution first. All right, without substitution first. Sorry. Okay. So the first thing I'm going to do, the notation with trig, I've said this a few times, it's a little bit goofy, so I'm going to rewrite this. I don't like the cosine squared 7x when I'm trying to do the chain rule because it's goofy. So I'm going to rewrite it as 1 plus, let's get the 1 in there, 1 plus cosine of 7x quantity squared, and then all of that to the third power. Okay, so you guys see the change that I made there? I also added in parentheses. I like the parentheses because it kind of shows me where the baby functions are. So inside of each parentheses, we have a 7x, and then inside of the next parentheses, we have the cosine of 7x, and then in the next one, we have 1 plus, I need another color here, we have 1 plus the squared function, and then finally we have the cube function. So we actually have 3 babies. I know, that's sad, isn't it? So when we take the derivative here, let's start with the mother function. So we have dy dx is equal to, the mother function is the cube function, right? So we're going to take the derivative of that and keep the babies inside. So we're going to have the 3 out front times the quantity of all that stuff, 1 plus cosine of 7x squared. And then that's going to be to what power? That's going to be to the second power. That's the derivative of the big mother. Sounds bad. Okay, so then in the purple circle, we have 1 plus something squared. So we're going to take the derivative of that. What's the derivative of 1? 0, right? So we're going to have 0 plus the derivative of cosine squared. So what is the derivative of cosine squared? Or all of that squared? What's the derivative of the squared function? It's 2x, right? Let's say it was x, and it would be 2x or 2u or whatever. So it's 2, and we're going to keep the baby inside. And this is kind of the tricky part here. We're taking the derivative of the squared function. So the derivative of the squared function is 2 times whatever the variable is. In this case, the variable is a cosine of 7x. So the baby of this function is going to stay inside, so it's 2 times the cosine of 7x. That stays the same. Because we're not there yet. That's the baby of the squared function. So right now we're taking the derivative of the purple function. In the purple function, I'm going to just kind of briefly use substitution here. If we say u equals the cosine of 7x, then inside the purple circle we have 1 plus u squared. And the derivative of 1 plus u squared would be 2u. Does that make sense? So then this right here, oops, that was weird. This right here is our 2u. Oh, you can't see the top of the 7, can you? Okay, does that help? All right. So now we've taken the derivative of the purple one. Now we need to go to the red baby. It's or pink, the pink one. This is the pink circle here. So what is the derivative of cosine? Negative sine. So we're multiplying by negative sine. We keep the baby of that function inside, so we still have the 7x inside. And then we have to multiply by the derivative of that one's baby, which is in the blue circle. What is the derivative of 7x? Hey, that one's easy, right? You don't have to simplify that. Actually, if you were doing this on a free response, obviously you don't have to simplify it. I've been talking about that all year. It wouldn't be a bad idea to multiply the constants together and put that negative out front. So you would have negative 42 out front, then times the quantity of 1 plus cosine of 7x squared times the cosine of 7x times the sine of 7x. But this would be an acceptable answer right here. What do you guys think about that? There was a lot of stuff going on there. The important thing with the chain rule, and it's easy, especially with a multi-level one, it's easy to accidentally take the derivative of two babies at the same time. So it's easy here to say, well, when I'm taking the derivative of 1 plus u squared, to take the derivative of the cosine at the same time. And we need to be sure that we don't do that. Every step along the way, you keep the baby the same and you take the derivative of the bigger function. And then you take the derivative of the baby. So, I don't know, what do you guys think about this? It is kind of fun, isn't it? You want me to do it with substitution?
Yeah,
Sounded like fun. Do you want me to do this using substitution or no? How many different variables would we have to use here if we did substitution? Yeah, you would need 3 variables, so you might use u, v, w. Yeah. All right.